A very good day to my dear supervisor Dr. Venkateshwara Perumal, my internal examiner Mr. Mohammad Saifuddin, and my external examiner Dr. Mazlim bin Mustafa. My name is Sri Venkateshwara. I would like to present my final year project presentation for Sedex 44. And it is about electrical impedance study of laser scribed graphene from Bio-polymer. This study revolves about laser optimization. To start off, sir, I would like to say what's the meaning of graphene. So basically, graphene is a honeycomb sheet of carbon atoms, and these carbon atoms has an impressive physical, electronic, and mechanical properties which just originate from this 2D electron confinement of one layer thick atoms. Next, there's a lot of qualities for graphene, but I would like to highlight the main six. The first one is the atomic thickness. The graphene's atomic thickness is just about 0.335 nanometers. The second one is the electron mobility, which is graphene is the highest between its theoretical limit, which is about 200,000 cm square per volt seconds, and this is 100 times more than silicon. The third one is the strength is extraordinary with a defect free and strong material which stands about 42 nano per meter, which is equal to about 130 gigapascal, which is stronger than steel. Okay, then the fourth one is the stretchability, which can be stretched up to 25%, and this value is relevant for any flexible electronics right now in the market. The fifth one is the transparency. It can be stretched. It can only absorb about 2.3% reflecting light, which is better than ITO, which is indium thin oxide. And then the sixth one, the last one, the thermal conductivity is about 1500 to 2500 watt per meter Kelvin. Okay, this is value is very quality, which is higher than diamond at room temperature. I would like to talk about the problem statement of my project. So there's three main problem statements. The first one is that it's a very high maintenance method because conventional methods before used high energy intensive methods to produce graphene. The second one is that conventional methods used before is highly risky because it produces byproduct which is very dangerous to the environment. The third one is that the conventional method used before, they use non-renewable substances like coal to make graphene, so it's not sustainable. Then thus the objectives, there's three main objectives. The first one is to develop thin lignin layer from powder material, lignin material. The second one is to study the effect of laser power parameter to get the best quality graphene. The third one is to test the properties of the graphene produced through characterization test. Thank you. For my project importance, I'd like to state in three main factors. So as my factors, the first one is that graphene has the best electrical conductivity because graphene can make ultra fast charging batteries that are also bendable because of the malleable property, and then they can also make supercapacitors that make batteries obsolete. That means we don't have to use batteries. They can enable small device production because they are synthesized in nano-sized particles. Thus they can make super fast desktops and also transistors. They can also make biosensors that can be able to use to check glucose level, cholesterol level, and DNase level in the human body. And then they are flexible, strong, and transparent, so they can make well-equipped sports equipment like tennis rackets, or due to their light material characteristic, they can make aircraft or armor and such materials. So to talk about my project normality, there are also signified that in three main factors. The first one is that my method uses graphene, which is low energy intensive method. The second one is the method does not produce harmful byproducts, thus it's safe and user friendly. The third one is that it's highly sustainable due to the source which is obtained from renewable sources, which is lignin, which is from tree barks. So on my next part, I would like to talk about methodology. I have signified that in four simple steps. The first one is material. Material, we used lignin material obtained from vascular plant tissues. The second one is that we use fabrication, which is using drop coating method and also Dr. Blade's method. The third one is machining. We use laser scribing machine with different laser power parameters to test which is the best graphene from laser parameters. Then the fourth one is the analysis is done using characterization test using Raman, PSAM, and also EIS. And then so on my left side, I'd like to show how I got my lignin solution. We tested it with 5 different solutions with 5 ml of NaOH, 5 ml of ethanol, and also 1 gram of lignin. And then the following solution is drop coated evenly on the surface of a glass substrate to get a homogeneity layer of solution. For table C, this is my table of laser parameter used with 60%, 80%, and 100% of laser power parameter with the same speed and same pulse per inches. Next up, I would like to talk about the equipments used for my project, and there are 6 main equipments I'd like to talk about. The first one is a hot plate. The second one is a screen printed carbon electrode chip. The third one is a laser scriber, which is a V460 machine. The fourth one is a Raman spectroscopy machine. The fifth one is an electro impedance spectroscopy machine. The sixth one is a field emission scanning electron microscopy machine. On my right side, sir, I would like to talk about the thin lignin film layer samples I got from my thin lignin material. The picture below shows my end product, which is my graphene samples placed on a SPE chip. On my last discussion, I would like to discuss about Raman spectrum. On my left side, Raman spectrum has three main bands over here. D band, which is the out of plane vibrations caused by the distorted structure in the sp2 connected carbon atoms. The value received over here is 1360 cm-1. For the G band is in plane vibrations caused by the sp2 connected atoms, and the value received over here is 1590 cm-1. And the 2D band is the second phonon second phase formation that causes right after the D band, and the value received here is 2723 cm-1. Both the G band and 2D band shows that the graphene is in stacked level order. Okay, as the laser power increases, the D band increases, showing that graphene undergoes defects, and the 2D band and G band also increases due to the graphitization increasing from the temperature ablation factor. Then, as you can see here or below, is the power against intensity ratio table. To summarize this table, I would like to say about the D band over G band. So basically, this ratio remains constant, showing that the crystallinity of the graphene is not affected by laser irradiation. The 2D band over G band value increases but achieves a value less than unity, showing that samples are multi-layered graphene samples. Then, to summarize this table, I would like to say that 60% graphene has the lowest intensity ratio, thus it has the lowest structural defects, and plus it has the best electronic transport properties. Next up, sir, I would like to talk about my field emission scanning electron microscopic results in discussion. On my left side is the top view of the laser scribed graphene, and with an equal scale magnification of 20 micrometer and also 500 times magnification. So the observation that we interpreted is the laser power increases and the gap between the graphene becomes smaller, and also it produces hole-like structures between the graphene flakes due to increasing graphitization level from increasing laser intensity. On my right side is the cross-section image of the laser scribed graphene with 2 micrometer and 200 times kilo X magnification. In these images, you can be seen a specific reference point. It shows that the thickness increases from 21.61 micrometer to 25.69 micrometer to 36.07 micrometer as the laser intensity increases from 60% to 100%. So for my last results in discussion, I would like to talk about the electrochemical impedance spectrum. So there's three main graphs I'd like to talk about. The first one is my Nyquist plot. The Nyquist plot has a semicircle trend for graphene. All the laser power intensity follows the semicircle trend except for 100% due to overheating on the graphene structure. Thus, it affected the carbon crystallinity of the graphene. The curve diameter at 60% graphene is the smallest, indicating that highest electrochemical conductivity at that graphene due to more one-to-one connections and also the lower resistance barrier between the electrolyte. The second graph I'd like to talk about is the phase angle against frequency graph. So this phase angle shows that for bad graph there is a phase angle of 100, for 80% graph 90, for 60% graph 80, and 100% graphene is 70 phase angle degree. The absolute phase angle is said to be 80 because the resistive losses is the lowest in this frequency region, making graphene act as a capacitor rather than a resistor. For 100% curve, however, although it's lowest, but still the line has not followed the curve, and it's due to the overheating of the graphene sample and over graphitization of the sample. The third one is the impedance against frequency graph, showing that as the frequency increases, the impedance decreases. As impedance decreases, it's also known as an effective resistance decreasing. So thus, as laser power reduces, the impedance reduces, making 60% graphene as the best graphene sample due to the lowest resistance rate and highest conductivity rate, enabling good mobility rate. To conclude my presentation, I would like to say that lignin thin layer was successfully synthesized and scribed, and the best laser parameter was 60% graphene to produce high quality lignin graphene. And this was proved by the Raman spectrum, showing that 60% graphene had the best electron transport properties, and the EIS spectrum also showed that 60% graphene has the best electrochemical properties. And for my future work, I would like to recommend that research has been conducted with different types of renewable sources to produce graphene material and to imply more variations of laser parameters such as speed factor and also pulse per inches factor to improvise on the graphene quality. And that is all for my presentation, ladies and gentlemen. Thank you very much for lending me your ears, and I hope I've made this presentation fruitful for my Sedex 44 presentation. Thank you very much.